Hi everyone. I hope you had a nice lunch and ready to listen about OpenStack and why it should be used and widely adopted everywhere. I believe it should. First of all, I want to introduce myself. My name is Dmitriy. I am an active member of OpenStack Technical Committee. I am a project team leader of OpenStack Ansible, and I'm a cloud engineering domain leader at CLUC. What CLUC, you will ask? Well, CLUC is a European cloud. It was previously named as City Network, and it has headquarters in Sweden. We provide a bunch of different services, including public cloud, compliant cloud, private cloud. We also have educational department, all cool stuff. We also have ISO certifications on information security, resilience, quality assurance, and environmental management. Only in public cloud, we currently have 6 regions, 60 terabytes of data, around 5,000 CPU cores, almost 6 petabytes of storage. Once the introduction part is kind of done, let's return back to our original topic. So the first reason is quite trivial, I guess, because it's open source. We all love open source, right? But it's not really trivial. So I think that open source is mistreated in a big way as of today and just used as a cool, fancy word for marketing of different organizations as of today. But open source is slightly more than just some part of code that is published on GitHub, and while the rest of the fancy stuff is provided only with paid subscription. But one of vital parts with OpenStack is that it's not only open source. We have a 4 opens principle, and open source is just one part of it. And yes, OpenStack is using Apache license, version 2, for all of its code. So it's quite fair, I believe. But then there is also open design, which is really, really vital part. So every development cycle, the OpenStack community holds face-to-face events to gather requirements and write specifications, doing community meetings, deciding on the future of the projects, on the future of how it will look like, what features do we need, what users does require us. So those events open to everyone, including users, including operators. Everyone came in and proposed what they think is important. So we are, gathering requirements, priorities, all that. But then it's also open development. So open development, we maintain all repositories we have are publicly available. Moreover, code review and blueprints and all decisions are also publicly available, so everyone can step in. Users can check on them. We are not hiding it, and moreover, they can step over and make adjustments and make comment, so you don't, you are not locked out from taking decisions. And then it's open community as well. So to build a truly open community, you need to balance 3 forces. It's users, ecosystem, and developers. And it might be sometimes quite tricky to do because developers sometimes are working for big companies and they're pushing their agenda. But then, yes, there are users who stand up and say, no, we want something different. And yeah, developers need to do something about that. There is also perception that open source is something just free, something that is given as granted. So you can just go, pull code, use it. Yeah, that's quite fair. But on the other side, it's not really free. It's just paid in a slightly different manner, and this is contributions. And contributions should be really treated as payment. I would say they're more investment rather than payment. Because companies that contributed to open source projects, they are able to capture as twice as more profit from these contributions as these who didn't. Because other organizations step in for projects they are interested in and say, oh, well, that's cool, we want also to contribute to this feature, and we want to add documentation, we want to improve CI testing. So it's kind of win-win situation for everyone to step in. And contributions are not really hard to do. So it's not requiring like technical knowledge of some programming languages. It can be just documentation, it can be translations, it can be bug reporting as users. All this is very important for projects to exist. So if you have using some open source projects, you see some bug, please create bug report. It will take you 5 minutes, but it will let the community know that you have a problem, and they will fix it, most likely. Then, reason 2, it's also quite political one, and it's digital sovereignty. It's a quite hot topic, I would say, right now in the EU overall. And basically this is because Privacy Shield has been fallen in 2020 by decision of European Court of Justice. So they have invalidated previous adequacy decision of European Commission called Privacy Shield. What it means is basically you cannot transfer data protected by GDPR to US-based companies, which makes super tricky to use hyperscalers like Google Cloud or Azure. It's not really legal, and especially when it comes to public sector or some financial institutions. So quite recently there was a case in Denmark where schools got in trouble for using Google products in their educational systems because it wasn't compliant with GDPR, and they were fined quite seriously for that. So it's kind of working. But to have that said, by the end of the 2023, there should be new adequate decision by European Commission. So it's been already kind of agreed with US that they will revoke some stuff. However, once they published first draft, it's not closing any key points why previous one was invalidated by Court of Justice. So even if it will be approved and taken in the current redaction, highly likely it will be just turned down quite soon again. So how OpenStack can help? Well, you can deploy on-premise cloud, and then all customer data protected by GDPR remains on your premises. Or you can take services from one of European clouds, and then data won't leak outside to US, and you will be compliant with GDPR. Then, worth to mention, OpenStack cloud providers are interoperable. So once you sign up for one cloud provider, you can quite easily switch to another one without a need to rebuild all your code or all your tooling for automation that brings up and spouts up your infrastructure, because OpenStack API is the same across them all. And there is a Sovereign Cloud Stack initiative that is funded by German government that basically ensures and provides the standardization on how sovereign European cloud should look like. And obviously, OpenStack is a key part of this solution. So, and it also standardizes like interoperability between providers that are part of this initiative. And yeah, it also enables you to comply with regulations, as I said before, and ISO certifications. And we include kind of proven that in practice that, yeah, you can do that. You can pass all like tick all boxes with it. So I think it's awesome. Third reason is variety of services. And in this context, I mean what OpenStack can do as a service. Because, as you might know, OpenStack by design is a set of microservices that interact with each other to provide functionality that kind of required and makes it infrastructure as a service. So core services to each OpenStack deployment has this. Its identity service, each image service, placement, compute, networking, block storage, and dashboards. Dashboards there are 2 right now, so basically Horizon is kind of conventional one, but there is new emerging project named Skyline, which has quite fancy look. It's quite good, but yeah, it's on its early stages, I would say, but yeah. And eventually, despite having so much services just for core functionality, it looks quite complex. But despite that, since each of them responsible for one specific part, and it's kind of yeah. Anyway. It takes like part in ecosystem. So once something goes wrong, you can kind of easily say which one has failed. So for example, if you can't upload images to OpenStack, yeah, then it's Glance, for sure. I mean, it's responsible for images. If you can't like create network, yeah, this is Neutron. Like, go check it logs. So it's kind of helping you out in determining what's went wrong. But next, I said that it's a variety of services, right? And I just showed you the core. So what are the rest of them? Well, here are they. So it's orchestration, which you can create infrastructure like with Terraform. Shared file systems, load balance as a service, containers as a service, database as a service, secrets as a service, DNS, and bare metal. What's actually interesting about like last 3, Barbican designated Ironic, that it can be used outside of OpenStack, so they can be used as independent projects. A good example is Ironic because it's widely used to basically bootstrap bare metal nodes and then install OpenStack on top of that. But it's not only about OpenStack. So Ironic is part of Metal 3 project. So you can basically scale your Kubernetes with bare metal machines with help of it. And since Antelope release, you don't even need to have Keystone for authentication because you can integrate them with CLUC. So it's quite good, I would say. Going next, variety of deployment options. There are a couple of community projects that allows you to deploy and operate your OpenStack, including some day 2 options like upgrades. So you don't have to pay gazillions of money to some enterprise that they like bootstrap your small like 3 machine or like 5 computes deployment. You can use open source one, official OpenStack projects. They're fairly easy to start with. They documented and have a friendly community behind them. So in case you're getting in trouble, you can reach the community, write to mailing list, reach out to IRC, say, hey, well, we have some issues, and they will likely help you. Of course, you can pay enterprises or consultant organizations, there are plenty of them, or you can even purchase courses to educate your staff if you want to take over after like some enterprise deployment. So it's always your pick how you will do this. But I will talk about community deployments. So it's OpenStack Ansible, Koala Ansible, Juju Charms, Puppet, it's Helm charts. And of course, you can also install with system packages that are provided by some distributions like Ubuntu and Debian and CentOS. If you're not fan of any of these, there is also Pipe packages published. So you can just pip install Nova. Yeah, easy. You can do that. But since I'm project team leader of OpenStack Ansible, I want to say a couple of words about it, obviously. So it can deploy in CLUC containers. It can deploy in bare metal. It can install services from inside virtual labs from source code. And we also do support distro packages provided by distributions. We are supporting Ubuntu, Debian, CentOS Stream, and Rocky Linux. And eventually in any mix of them. So if you want to change distribution, it won't be a problem. You just spawn up new nodes with new distribution and kind of slowly or fastly migrate out of it. I guess it's time for the last reason. It fits any scale. Quite recently, lately, I've heard a lot that OpenStack fits good only for big deployments. I'm deaf now. And it's my fault, actually, so nobody to blame, right? Yeah, so I decided to address this point because I heard a lot about it. Well, let's imagine full-scale deployment. So you have like multiple regions. It's region A. You have multiple availability zones inside each region. And then you can also have multiple cells of compute if you want to address scaling issues, because if you have like more than, I don't know, 300 computes in single region, single deployment, you might want to separate them in cells already. Because messaging is complex. Oh well, it's not complex, but it's, yeah, it's making load and not scale too much. Yeah, so, and then you have like net nodes, separate stack of net nodes where traffic will go in and out, and you also have a storage solution. It can be like something like Ceph, or it can be some enterprise purchase for Dell, or yeah. Pretty a lot of storage options, to be frank. Like lately drivers are like, I don't know, at least 20 of them for sure right now in tested in pipeline. So, but what about small scale? So let's see what we can do in minimal available architecture. So you can do hyperconverged deployment. So you can go, if you need high availability, you can go as least as 3 nodes because you need clustering, and clustering will, in split brains without quorum, it will be really bad. So you need at least 3. And then you place all API services. And then you have all API services there. And you can collocate libvirt and Chemo and net nodes. You can do everything on these 3 computes. So yeah, it's basically control nodes, computes, network nodes, everything in one. You can do even like add Ceph to them with block storage. So they will be migratable. You can fail over VMs between. And what's good about this, we actually can scale it up. So there won't be like any problem if you want to move OVN out of, or OVS outside of this to some independent node. And you can do like basically with every component, you can just move them out when you grow up. But if you want like some really small lab, you can just have one machine which will have everything on it. Like, I don't know, home DNS or something, I don't know. So in my opinion, you can really do small deployments at small cost without real issues for that. And that's kind of it. I saved a couple of minutes for questions, if there is any.
Questions?
Not a lot. OK, thank you.
Yeah, okay, thank you.